Hi, this is Aaron with iBoard Repair, and today I'm working on an MSI RTX 2070 that is not working correctly. It's right here, it's a nice looking card. Let's just plug it in and see what it's doing. Okay, I have this card plugged into the motherboard. I'll turn it on now and we can see what it's doing. So the motherboard will boot and we will get image. However, we do have some problems. We have low resolution. And if we go over here to Device Manager, we see that we have code 43. So we can just shut this back off. So code 43, that can be a VRAM module. So we're going to use the Matson Mod software to see if we can scan it and see if that's the problem. To do that, we will need our Matson Mod software on a USB stick here. So we can run this and it will generate a report that can tell us what's wrong. Very useful software, and it's kind of cool to look at, I guess. This is testing the different memory banks, and it's going to find some errors, and it's going to tell us exactly, not always exactly, but a lot of the times it will give us a huge hint as to what's wrong and how we can fix this card. So we get a fail message right there, and then it shuts down. We can power it down and read the report it generated for us on the USB flash drive. So let's do that. We have our USB stick plugged in. Let's take a look at the report that was generated within it. So C1 has all the errors. I don't know much about reading these reports. I do know that C1 has all the errors, so we should change that VRAM module, and this card should work after that. So simple as that. So I will go ahead and take apart this card and we can take a look. So I have the board exposed here. Let's take a look and I can tell you which one it is. Here's the GPU. It goes A1, A0, B1, B0, C1, C0. C1 is the problem. I pulled off these thermal pads a second ago off camera. Well, it was actually on camera, but I didn't realize that I didn't have the scope cam on. This guy's a bad guy. It looks like they have Micron memory. I do have a donor here, it looks like. So this should work. I will have to reball it, and I don't actually have a stencil for this yet. So I'll either have to order it, or I'll see if one of my iPhone stencils can possibly work. I don't really know. Either way, I can show you the process of removing this now, and then we can check to see if we have a stencil afterwards. So we'll do that. So I'm going to go pretty high in temperature. I'm pretty high in airspeed. I'm wondering if I should take the nozzle off completely, or if I should just use my biggest nozzle like I'm doing. I guess the biggest nozzle should be fine. I do have a little plastic piece up here I need to watch out for, but it's kind of far. I think I should be okay. Just in case. Just put up a little barrier there. So I'm just kind of heating up the board around it because I don't want the GPU to go through such an extreme change in temperature. And then I'm going to add a lot of flux and I'll heat up the chip directly. I may need to up my heat. Turn up my heat a little bit because it's not wanting to lift. I'll add a little bit more flux. I think I'm going to go at this angle instead. So you definitely don't want to launch the chip like that, but shouldn't be too big of a problem. No pads ripped. No melting there. The reason no pads ripped is because I used enough heat to allow the chip to come up. A lot of people will pull these chips before they're ready to come up, and that will cause pads to be ripped. And then they'll say it was because the board was bent, but it's most likely because they didn't use enough heat. So let's see if if I have a way of reballing that donor that I have. I'm not sure. So it does not look like I have any stencils that are going to work with this that are from iPhones. So I ordered some universal stencils. Should be here in a couple of days. I will be back at that time to reball this and hopefully come to a conclusion. Okay, I'm back today. It's a new week. I have my VRAM here. I'm going to show you guys how to reball it. I didn't get the perfect stencil, but it's the right size at least. So I'll be able to reball this with this. Reballing is not too hard. It just takes some practice. I have a few people now that are watching me from GPU repair community, and GPU repair community are like a little bit less experienced when it comes to like actually physically soldering things, as opposed to the iPhone repair community that's a lot more used to it, I think. I don't know, that could be wrong. It's just from the people that I know. Alright, to reball this, I'm gonna first remove the solder that's already on here. And change my iron tip real quick. Right. So it looks like this chip's probably already been reballed by someone. I pulled this directly from a parts board that I have, just because it doesn't look like original solder to me. So first, just remove the old solder. You want to make sure none of the pads are gray. Like I'm seeing down here at the bottom, I'm going to have to make sure those are okay to take new solder. Sometimes these don't like to take it, so you just kind of scratch it and touch it with the iron again, and then once it's scratched it will usually take it, no problem. It's quite interesting seeing the different types of technicians between like the iPhone people and the GPU people. Okay. So those pads are ready to take solder now. I do have a dog groomer next door to me, so I apologize if you hear a crying dog. They do cry sometimes. Okay, so I have the chip clean enough, so let's reball it. I think I'm just going to do half at a time to make it easiest. So I like to reball with the solder paste. I've seen a lot of people reball these things with solder balls, which is fine too. It's just whatever you prefer. I've always used solder paste, so that's what I'm going to continue to use. I like to dry my solder paste just a little bit before I use it, if I think the reball might be a little bit difficult, which this one it might be because it's not the right stencil exactly, it's just a universal one. So it might be difficult, who knows. It's going to be hard to get this thing flat, but if I can, it should be okay. I think I will try to spread it with my left hand and just have this right hand holding down with the tweezers the whole time. I apologize if you can hear these dogs next to me. We have noisy ones today. It's my groomer next door. Okay, that's probably the best I'll get it. Let's just spread it onto here. Because this stencil's kind of far away from the chip, this is going to be a little bit more difficult, but hopefully it will come out okay. Normally I wouldn't do half at a time, but because this isn't, like, again, because it's like a universal stencil. Look, I don't even think I'm lined up properly. Let's just see. I'll try it anyway. So that might be good enough. Let's see. Looks like I missed the line, but that's fine. I'll just take some of these other balls that were made and put them there. This doesn't look like it's exactly the right size, is it? Some of these are a little bit big, but it's okay. I should be able to reshape them a little bit. I'll show you how I do that. Also, it looks like I missed a whole line over here, so I'll put these on. If you ever didn't have solder balls, this is also an easy way to make them. Just put in a stencil and heat it up, and then it creates the balls. So I have two ways to handle the big line right here, because these are a little bit bigger than the rest. I could either redo that line, or I can do like a little grinding method. I think I'm going to do the grinding method. I'll show you what that is. Normally a reball should be very fast and easy, So this is not a great example of the first reball I'm going to show on this channel for these RAM chips, but again, I didn't have the right ball or the right stencil. That's what I'm going to blame it on. With the right stencil, it's a lot easier. These universal ones can cause a little bit of a problem. So this isn't the ideal way to reball this, but again, people have different methods, so maybe this will help someone that has like a mess up on their reball attempt. Okay, not bad. We'll do the other side now. So I'll try to do the same thing and just get the bottom little bits on here. Where's my knife? Oh, here it is. Oh, I see why the middle ones are a little bit bigger too, because there's more space up there with how I'm putting this paste into here. But I should be able to make it work. I think versatility is probably the most important skill when it comes to micro soldering. I'm going to ignore that phone call because both my hands are full, so sorry for the noise. So those look fine again. Okay, this doesn't look too bad. Excuse me one moment again. Okay, sorry about that. I get a lot of phone calls. My wife had a baby, so she's not here taking the calls anymore. And it can be difficult and a little bit annoying to have to answer phone calls and deal with walk-in customers while I'm trying to repair. But we do what we have to. Okay, so like I was saying, this is reballed now, but you know, it doesn't even look very bad. These middle ones are just a little bit bigger than the rest, but not to a big degree. There's a couple of them that are a little bit bigger. Either way, I'll show you how I even these out. It's just with a sheet of paper. I just rub it against it. I'll show you that right now. Let me grab that. Okay, to even out these balls, easiest way, piece of paper, take the chip, and just grind it. This is going to flatten the balls that are sticking out the most, obviously. So you do this a couple of times. It will flatten some of the balls, and then you remelt them so they shape back into balls, and then you do it again. And you just repeat that process, and that will slowly reduce the size of the biggest or the oversized balls that you have. So it may be just a little bit difficult for you to see, but these middle ones and some of the other ones that are kind of big, they have a flat surface on them now, where some of the smaller ones like these ones, they weren't really touched at all. And that's, you know, the easiest way to get them all to be about the same size. So I do that once, and then I'll just go ahead and remelt all of this to create balls again that aren't flat. And then I'll do that process again. And I'll do that, I don't know, 3 or 4 times when I feel like the balls are really uneven. And that will just make it so it all sits flush when I put it back onto the board. So I'm going to repeat this process a couple of times, and I'll be back with you when I'm finished. So this is what the chip looks like now. It's reballed. I actually, I only flattened it like one more time. I really didn't do much else to it. I didn't even bother heating it one more time. Having it flat at the last one will just kind of make sure that everything is the same level when it goes on the board. So let's put it onto the board now. We also have to prepare the board to be ready to take this chip by flattening and removing the old solder that is still there. So here is the GPU. So let's clear away this old solder first. I'm using a low temperature on my hot air just to assist with keeping the board at even temperature. Not that many people do that. I don't know why. I have always liked to do that. hot air is just at 200 degrees, so not really enough to do anything on its own, but still, I mean, it's kind of hot. I'll go over this one more time with leaded solder on my iron, just to like kind of prepare these pads as best as I can. So when I'm done, this solder will be a lower temperature than everything else around it because I'm using leaded solder. Leaded solder is just superior. Just use it. The only reason these manufacturers don't use it is because it's like you can't use it in mass production because it's bad for the environment. But in rework, just use it. I could flatten these pads even more if I really wanted to. Like I can go in there with a braid, copper braid, and really flatten them all the way, but I don't think it's necessary. I will try to see if I can cut some of them a little bit. That's not really recommended unless like you've done it a lot and you know what a pad can take and what it can't. Okay, I'm fine with that. So this should be good enough now to put the chip onto. So I'm gonna have to pause the video. I'm sorry I had that air on the whole time. I didn't really need it on and it was really loud. I'm gonna pause the video and go back and reference it so I can see the orientation of this. Oh, actually it tells me right here. Right? Yeah, dot goes to the thing. Dot goes to the thing and the dot. Dot goes to the thing. Okay, yeah, so no problem. That's the orientation. Here's the chip. Add some flux. I don't know if it matters, but I have a preference to solder like the wider way rather than the taller way when I'm using hot air. That might just be my own preference, I don't know. So I'm going to use a slightly lower temperature to like set this into place, and then I'll come in with a higher temperature to finish it. Also, the nozzle I'm using is not big enough, so let me switch that. So I assume this is partially attached, enough that it probably won't move. It might not be attached enough, but I think it's partially attached enough now that I'm going to add more flux, and then I'm going to crank up the heat to where it should fully attach. I had a little bit too much coffee this morning, so my hands are feeling a little shaky, but you learn to work with that. It's the price you pay for drinking coffee. So I just want to see this chip like twitch one time, and then I know it's like going to be all the way attached. If it's in like perfect orientation, it won't twitch, but that's not usually the case. I am also using a lower melt solder on here than everything around it, so it should go. It might already be in place. I think I'm just going to take a look on the side to see if it looks attached or not. And it's clearly not all the way attached. You can see on that left side there. Is that the left view? It's harder for you to see than it is for me, but it's not all the way attached. So there's a couple ways you can do this. You can either like do a little tap test where you're tapping it while you're soldering. Let me take this call real quick. Okay, so yeah, let's just heat this up again. Particularly is right here that it looked like it was a little bit lifted still. So I think I'm just going to try my best to see if I can see movement there while I'm heating this up. Alright, I'll do the tap method because it's just it's hard to tell. I'm still not that used to soldering on GPU boards, and iPhone motherboards take so much less heat. Okay, it looked like it finally moved into place. So we can look again on the side. And that looks much better. It looks like all the rest of them now. So I'll clean this board up and then let's plug it in and see if it works. I guess I should check for shorts first. Let's see. I don't really know where things are on this board, so I think that's the memory. Everything looks fine. I'm gonna just clean it up and plug it in and let's see. Okay, I have the fan and heatsink back connected, so let's plug it in and run a match test because we saw that fail before. So I'm curious to see if that will pass this time. I hope it powers on still and gives us image still as well. I assume it does, but I don't know that. Looks like everything's connected. Okay, fan spinning, lights are on. That's a good first sign. You can give me image now. Cool, image. Good to see. I don't have my keyboard connected, but I have it right here. Okay, match is starting, that's good. Where did I put the mouse? It's over there. Cool. We passed. So that's great. That is great. Let's see if it boots into Windows now. Cool. Cool. All right, let's see. It will download drivers. The image doesn't look distorted like it did before. I'm gonna go grab the mouse. So far, so good. I think we're good, yeah. This device is working properly. Let's open NVIDIA control panel. Yep. NVIDIA GeForce RTX 2070. So, this card is repaired. That was great. That was the... You're going to have to take this call. So NVIDIA GeForce RTX 2070. It looks like it's working. This is great. It was a bad VRAM, and this is the process to replace it. So I hope you learned something. I'm glad you stopped by and watched this video. If you can, give it a like, and if you're not, please subscribe, and I'll see you next time. Bye.